All right, so you should be on page 16 with me. And we've now been solving a lot of 1 and 2 step inequalities. And now it's time to practice some of our skills of translating and apply them to a real world problem where we can write an inequality and solve it to answer that real world problem. So here we go for this first example. All right, so we got Jack. Jack fixes cars. He charges $100 as a flat fee for each car, plus $15 per hour. How many hours does he have to work on a car if he wants to earn at least $250? So basically what this means, folks, is that no matter what, Jack is going to earn $100 for working on a car. Now, what happens is that because some cars are more difficult to fix than others, and sometimes when you pop the hood, you take a look and you realize it's going to end up taking way more time to finish than originally thought. What Jack does is also charges $15 per hour. So in this chart, what we have is we have all of the words to help you guys kind of break down all of the parts. And that $15 per hour, that's going to be the coefficient with our variable. $15 per hour. And of course, we're going to add that to the $100 that he's going to make as the flat fee. You might remember from our previous unit that the flat fee is always the constant. Now he needs to earn at least $250. So all of this over here, that $100 plus the 15 per hour, we want that to be more than or equal to the $250 that he has to earn. So now what we can do is we can take that inequality, the $15 per hour plus the $100 that he's going to make no matter what per car, is going to be greater than or equal to the $250. So what that means is to earn $250 right here, Jack would need to work on the car for 10 hours. Now some of you might be thinking big picture, well, what if the car doesn't take 10 hours to fix? You're totally right. If the car doesn't take 10 hours to fix, then obviously Jack is going to have to move on to another car. But right here, if we just assume, to keep the problem nice and easy, that Jack is going to be working on one car, and he doesn't know how long it's going to take him, so he's going to charge $15 per hour, plus he wants to make sure that he's going to make some money for his time. He wants to charge a $100 flat fee because what if it doesn't take very much time to fix the car? He needs to still get paid. So again, in general, the $15 per hour that he's working, that's going to be the labor, plus the $100 is going to be more than or equal to the $250. When we drop our line and solve, we see that Jack has to work at least 10 hours. All right, now for the next practice question, I want you guys to read along with me before we try to fill in the boxes. So you have $50. You bought a backpack for $20. You also need to buy pencils that cost 75 cents each. So it sounds like we're getting ready for school. At most, how many pencils can you buy with the money that you have left? We want to write and solve an inequality that represents the number of pencils. Now this one's going to be a little bit tricky because you might be thinking instantly to go ahead and minus $20. But let's take a look at the chart. In all of these words here, the coefficient, the variable, the operation, the constant, the symbol, and the total, let's take a look at the coefficient with our variable. I don't think anybody's going to fight me on the fact that if the pencils cost 75 cents each, that's going to be over here, my 75 cents per pencil. Now the thing is that the pencils cost us 75 cents each, y'all, and then we're going to add the $20 that we spent on our backpack, and that total has to be less than or equal to the $50 that we have to spend. So notice that the part where you bought a backpack for $20, we do subtract the $20 when we solve the inequality. But first, from the beginning, our inequality is going to be that it is 75 cents per pencil plus a $20 backpack has to be less than or equal to the $50 that we have to spend. So in this chart, it just kind of helps you break down the parts, that the coefficient is the number before the variable. Then you're going to add the $20 because the backpack costs $20. And the 75 cents on the pencils plus the backpack has to be less than or equal to the $50 that you spend. When we drop our line and solve, we subtract that $20 for the backpack. Then we have $30 left over. Now that $30 that we have left, we can divide it by the 75 cents per pencil, and see that at most we can buy 40 pencils. The number of pencils that we can purchase is less than or equal to the 40. Okay? Now let's read the next question before we take a look at the chart. Folks, you can pause the video at any point if you need to. Feel free to pause the video at any time. Irving is trying to raise $750 for a 7th grade dance. Now they've already made $100. That's great. Okay? If they sell raffle tickets for $5 each, how many more raffle tickets must they sell to make at least $750? So again, we're trying to raise $750. Now we can also, of course, raise more than that. That would be great. Okay, so the total that we're trying to get to is $750 right here. We, of course, with all of the money that we're going to earn, we can earn over here. All of this stuff over here can be more than or equal to the $750. $750 here is a minimum. Now we're going to be selling tickets, raffle tickets for $5 each. So there's my $5 per raffle ticket. Okay? They've already made $100. So there's the part where I'm saying the $5 per raffle ticket plus the $100 that I've already made can be more than or equal to the $750. So when we solve that inequality, first thing we're going to do is say, all right, we've already made $100, so we're going to subtract that. So if they were trying to raise $750 and already made $100, now they only need to raise $650. If they're going to be selling raffle tickets for $5 a ticket, when we divide both sides by the 5 here, we'll see that the number of tickets has to be more than or equal to 130. So they need to sell at least 130 tickets. And as long as they sell at least 130 tickets, they'll have made enough money. So that concludes page 16. And now we're going to turn over, and we have one more problem for page 17. Victor is planning a ski trip that would cost him $450. So far, he has saved $200. If he earns $8.50 per hour working at a grocery store, at least how many more hours does he have to work to save enough money for his trip? So once again, we're trying to raise $450. And all of the money that we're making over here can be more than or equal to that $450. Now, he's already saved the $200. All right, we've already got that part taken care of. And he's going to earn $8.50 per hour working. So when we solve, we're going to subtract that $200 that we've already saved. Now that $450 minus the $200 means that Victor only has $250 left to save for his ski trip. If he's going to make $8.50 per hour, we can divide both sides by the $8.50, and we're going to get a decimal in the calculator. Let me make sure you guys see what happens in the calculator when we take that $250 that he still has to earn and divide it by the $8.50 he makes per hour. This is the decimal that we get in the calculator. Now, if we round this down like it would normally round down to 29 hours, 29 hours won't be enough. If he only works for 29 hours, 29 hours times $8.50, he'll only have made $246.50. And he needs to make at least $250, so that won't be enough. So he'll need to work at least 30 hours. We're going to round this one to 30 hours, even though 29.4 would round down. We have to round this up to see that the 30 hours times the $8.50, that's going to be more than $250 that he needs. So for the last one here, it was at least 30 hours. And that takes care of page 17, which means at this time, the inequalities packet should be complete. Thank you.